3rd, like the syllabus says, and it's going to cover all the sections up to planes. So what we just finished. So 1 second. So that's going to be section.
I think you're muted.
He's definitely not muted.
Oh, sorry. Can you hear me?
Yes.
So I think that that's going to be sections 12.1 until section 12.5. So basically what vectors are, surfaces, vectors, curves, cross products, dot products, things like that. I put on Canvas, I put a review for the test. I'm going to also add a couple of different practice tests for you guys to do. And we're going to go through a couple, well, we're going to go through one practice test today. So today and Tuesday are going to be review days. So we're basically going to review the material. If you have any questions, don't hesitate to ask. What else? Any questions? Okay.
I have kind of a format question.
Yep.
Will the exam be the same format as the quiz?
No. So I think so first thing, I don't make the exam. There's a course coordinator, and he's going to make the exam. I believe you're going to have 4. So he's in charge of all of that. I believe he will get in contact with you and tell you what you're supposed to be doing. But I believe there are going to be 4 different periods when you can take the exam. But you have to choose one and take the exam during that period. And it's going to be, I'm not actually sure how long it's going to be. I wasn't told. So that's something I'll let you know, or someone will email you about that. My guess is it's going to be like between 1 hour and 3 hours, but I know that's a big difference. Probably 5 questions. So it's going to some degree, it's going to be like the quiz, but it's probably going to have less time. And you're going to have to do it during a specific period. So you won't have, you won't just be able to show up and do it whenever you want. Any other questions? Okay, so here's one of the practice tests. And like I said, I'm going to, I'm going to add a few of them to Canvas. And I also, most of the videos that I made, most of the recordings that I made are already on YouTube. I'm going to add this recording and a couple of other ones, so you can also look at that to review. And again, you can also talk to me. So, okay, so let's begin. So question 1, they say consider the vector A and the vector B. And so first they want us to find the angle between the vectors A and 10A cross B. So we know that 10A, we know that 10A cross B is the same as 10A cross B. And we also know that A is orthogonal to A cross B, which tells us that A is orthogonal to 10A cross B, because this just multiplies the vector by 10, but it doesn't change the direction. So it's 90 degrees. So the answer for number A is 90. Then they ask us to find the angle between the vectors A and B. So can anyone tell me what the vector A is?
Is this posted on Canvas somewhere?
I am going to post this on Canvas. I have not already, but I am going to put this on Canvas. There should be a page. In Pages, there should be a review section, but I have not yet posted these tests. Yeah, sorry. So what was it? 7,
2, 4.
2, 4. And B is equal to
2, 1, 2.
2, 1, 2. So the angle between two vectors is equal to cosine inverse of the dot product between them over the magnitude of A times the magnitude of B. So this is equal to, so first we need to figure out what the dot product is. So A dotted with B is equal to 14 plus 2 plus 8, which is equal to 24. And the magnitude of A is equal to the square root of 7 squared plus 2 squared plus 4 squared. And I'm not really going to do that. And the magnitude of B is equal to the square root of 4 plus 1 plus 4, which is equal to the square root of 9, which is equal to 3. So then that would mean that this is going to be equal to cosine inverse of 24 over the magnitude of A, so whatever that was, times 3. Any questions about this? Okay, so then the next question, they ask us to find the angle between the vectors A and 2.7A. And this just multiplies A by 2, so the angle between these two vectors is going to be 0. And then they ask us to find, one second, find a vector of length 3 in the exact opposite direction of A. So the way to do this is by first, let me erase this. So we can first divide by the magnitude of A. So we can look at A divided by the magnitude of A. So this has magnitude 1, and we can multiply this by 3, but actually we should multiply it by -3 because we want to go in the opposite direction. So this is a vector with magnitude 3, and it's the opposite to the vector A. So it's going to be equal to -21, -6, and -12. All of these all over the magnitude of A. Any questions? Any questions about this?
Can you re-explain the first part where you got 90 degrees?
Yeah, so 10 A cross B. Well, you can either think about it like 10A, so you have here is A, and here is B. So 10A, you can think about it as 10A, so same direction, just much, much bigger, which means that the cross product of this is just going to be this. Well, one vector was like this, let's say. Let's say that this is the cross product A cross B. So then 10A cross B would, let's say, look something like that. So this would be 10A cross B. But it's still orthogonal to A. So it's 90 degrees. Yeah?
But how did we know they were orthogonal?
So we know that A cross B is orthogonal to A. Because that's just something we've been looking at. And again, that would tell us that 10 A cross B is orthogonal to A. Another thing you can do is, we know that this is equal. You can move the constant in here outside, so it's 10 A cross B. So this is another thing we can do. And this is orthogonal to A. So this is orthogonal to A because it's just 10 times that vector. Just makes it bigger. Yeah?
All right, thank you.
Okay. So next problem is they want us to find the equation of the plane that contains this line and this point. So first, just in theory, to look at to see what we're going to try to do. Let's say this is my point P and this is my line, and I want to find the plane that contains the point P. Okay, maybe. So it contains the point P and it contains this line. So one thing I can do is we already know that if you have 3 points, so if I have 3 points, this is the point P, Q, and R, then the way to find the plane that contains these 3 points, does anyone remember how to do it? So we create the vector PQ and PR. So that's the vector PQ and the vector PR. Anyone know how to continue from here?
The cross product of them is your normal vector.
Yeah, so the normal vector is going to be equal to the cross product of PQ cross PR. So that's going to give us, so here's my plane. So that's going to give us this vector over here, which again is orthogonal to both PQ and to PR. And that's how we can find our normal vector. And then, like we said, the equation of a plane is AX plus BY plus CZ is equal to D, where N is equal to A, B, C. So that's the normal vector. You read it off these coefficients, right? And your D is equal to, so if you have some point, let's call this point P0, and it's going to be the point X0, Y0, and Z0. So your D is going to be A, X0 plus B, Y0 plus C, Z0. So that's what you do when we have 3 points. So in our case, well, first we can find R0 on the line. So let's choose this to be R0. It's a point on the line. And we can then find the vector R0P. And then we can use the vector V, because the vector V is also going to lie in the plane. It can kind of correspond to the vector PR. So this is going to be the vector V over here. So now that's the vector V. And then our normal vector is going to be R0P cross V. So that's going to be our normal vector to the plane. So that's going to be this vector over here. And then we can use, let's say, the point R0 to find D. So that's, in theory, what we're about to do. So any questions about this? Okay. So can someone read out the line for me? Well,
I don't know if anyone got a chance to write it down before you switched screens.
oh, I apologize. Okay. 2 plus 3t. Okay, 2 plus 3t. 3 plus 2t. 3 plus 2t. And 2t. And the point's 2, 5, 5. So my point P is going to be 2, 5, 5. Actually, let me write it a little lower. Okay, so this is the same as taking the point 2, 3, and 0 plus t of the point 3, 2, and 2. And again, this is the same as R0. So this is my R0. And then plus T V. So this is my V. Okay. So now I want to find, so again, here's my point, here's my line. So we want to find the vector V, which we already have, and we want to find the vector from R0 to P. So we want to find the vector R0P. Okay, so R0P is equal to, so it's going to be P minus R0. So it's going to be 0, and then 5 minus 3 is 2. 5 minus 0 is 5. So this is going to be my R0P. And now I want to find R0P cross V. And this is going to be equal to my normal vector. And this is equal to I, J, K. And then we're going to have R0P, so that's 0, 2, 5. And your V is 3, 2, 2. So this is going to be equal to I times 4 minus 10. So that's negative 6. Minus J. That's 0, so minus 15. So plus 15. Plus K. So that's 0. And this is minus 6. So now we have that our normal vector is equal to negative 6, 15, negative 6. So this is going to be the normal vector to our plane. Any questions about this so far? Okay, so.
Can you scroll down a little bit?
Yep. Actually, I can in general.
That's good, thank you.
Okay, so now so we're going to have negative 6x plus 15y minus 6z is equal to our d. It's equal to d. So this is how the plane would look, and we just need to figure out what d is. So we can choose any point that's in our plane to plug into here to figure out what d is. So we know that R0 is in our plane, and it's the point 2, 3, and 0. So we can plug that in here. So we get negative 6 times 2 plus 15 times 3 minus 0 is equal to d. So d is going to be equal to 45, so 33. Negative 30, maybe.
No, that's right. 33 is right.
What? Sorry?
33 is right.
Right. Okay, thanks. So now we're going to have, so our plane is going to look like 6x plus 15y minus 6z is equal to 33. Another point that we wanted in our plane was the point P. So P was equal to 255, 255. So let's just make sure that that's in our plane. So that's negative 6 times 2 plus 15 times 5 minus 30 So the question is this equal to 33? Let me just do this in calculator quickly. So it's basically 75 minus 30, which is 40 minus, yeah, looks right. Make sure. Yeah. Okay, so any questions about this? So again, you just look for two vectors, you take their cross product, that will give you your normal vector. You use the equation of a plane, you find what your D is by using one of the points, and that gives you the equation. Okay, so let's go on to the next problem. So the next problem, they say, consider the sphere given by this equation. Find the center and the radius of the sphere. So let's first do that. So we have x squared plus y squared plus 4y plus z squared minus 4z is equal to 13. Is this correct? Yeah. And okay. So in order to find the equation of the sphere over here, we just need to complete the square. So the x squared just stays the same. So you have x squared over here plus, and then you're going to have y squared plus 4y plus 4 plus z squared minus 4z plus 4 is equal to 13 plus 8, which is equal to 21. Any questions so far? Okay, so then we're going to have x squared plus y plus 2 squared plus z minus 2 squared is equal to 21. So the center is going to be the point 0, -2, and 2. And the radius is going to be the square root of 21. Any questions? Okay, so the next question that they ask is find the shortest distance between a point on the sphere and the point 5, 2, 3. So 5. So if this is my point 5, 2, and 3, and here's the point on here's the center of the sphere, 0, -2, and 2. Well, we can think about a little sphere around here, and then we are looking for the shortest distance from this point to some point on the sphere. Well, what we can do is we can look at the distance from this point, to the center of the sphere, and then we can subtract from that. We can subtract this over here, and that will give us this distance. But we know that this over here is the square root of 21. So we only need to figure out the distance from here to here. So what's the distance from there to there? So let me call this point Q, and let me call this point P. So we're looking basically at the magnitude of the vector from P to Q, which is equal to the square root of 5 minus 0 squared plus 2 minus 2, which is 4 squared, and then plus 3 minus 1, which is 1 squared. So this is going to be equal to the square root of 25 plus 16 plus 1 which is going to be equal to the square root of 42. So the shortest distance from this point to the surface of the sphere is going to be 42, the square root of 42 minus the square root of 21.
Why would the Q not be the center of the sphere and the P be the point, or does it not matter?
It doesn't matter. Yeah, I just wanted to go from P to Q so I can have 5 minus 0 and 2. I don't know. I just thought that it'd be easier to do. Anyway.
All right, just making sure. Thank you.
Okay. So the next question. They find the values of C so that this line does not intersect with this plane. So if we have a plane, so let's first go to, so here's X, Y, and Z. Let's say you have a line here and we have a plane and we do not want them to intersect. And we already know almost the entire equation for the line, except for there is a C over here. So any ideas for how we can make sure that the plane and the line don't intersect?
Make sure they're parallel.
Yeah. So if here's my normal vector to the plane, and this is my vector V on the line, then what we want is we want that the normal vector dotted with V should be equal to 0 so that they're orthogonal, which means that then this line, the vector V will be orthogonal to the normal vector, which means that this line will be parallel to the plane, which means that it won't intersect the plane, right? So let's do it. So first for the line, they have R of t is equal to 2 plus t, 2 plus t, 2 minus ct, 2 minus ct, and 3 plus t, 3 plus t. And the equation for the plane here is 5x plus 3y plus 2z, 5x plus 3y plus 2z is equal to 7. Okay, so now my normal vector is equal to the vector 5, 3, and 2. And the vector V is equal to, so this over here is going to be equal to 2, 2, 3 plus t times your vector V, which is 1, negative c, and 1. So my V is equal to 1, negative c, and 1. So now let's take their dot product and set it equal to 0. So that's going to be 5 times 1 minus 3 times c plus 2 is equal to 0. So that means the negative 3c is equal to negative 7. Or in other words, c is equal to 7 over 3. Now, we have to make sure, So what we just did is we had a plane and we found a C that made this line hopefully, well, it's definitely parallel to the plane. We need to make sure that the point R0 did not start in the plane, so it's not entirely contained in the plane. So that's what we need to make sure now, which means, so one way to do that is to take the point R0 and plug it into your plane and see if it satisfies the equation of the plane. So that would be 5 times 2 plus 3 times 2 plus, again, 3 times 2 is equal to 7. That's the question. And the answer is no, it's not. So this is not in the plane. So this point is not in the plane. So it's probably here, wherever. And then our vector v is orthogonal to the normal vector. So our plane and our line are parallel. Any questions about this?
Can you please repeat that last part you were talking about when you highlighted the 0.223? I was writing stuff from the bottom.
Yeah, so 1 second. So what I was saying is that we need to make sure that this point over here, that the we need to make sure that the entire, we found the line that's parallel to the plane, but we need to make sure that the line is not now contained completely in the plane, meaning that the point over here, let's say, is not in the plane, and then V would be contained in the plane, and the whole line would be in the plane. And the way to do that is by picking any point in the line. You can pick any point you want and showing that it's not in the plane. And if it's not in the plane, it means that it's somewhere else, and that then the line and the plane never intersect. Yeah. So the way we did that is we took the point, we plugged it into the plane, and we showed that it's not equal to 7, which means that this point is not in the plane, which means that the entire line never intersects the plane.
Okay,
Yeah.
that makes sense. Thank you.
Okay. So now they want us, okay. Now they want us to consider the point A, B, C, and D. Find the area of the triangle ABC. Find the equation of the plane containing A, B, and C. Is there a plane that contains the point A, B, C, and D? So these two we can do basically in one once. We want to find the well, we just want to find the normal vector to so let's just okay, so the point P that they gave us was equal to oh sorry, A, 3, 2, 1. So point A, 3, 2, 1. The point B is equal to 4, 5, 6, 4, 5, 6. The point C is equal to 4, 0, and negative 2. Oh, sorry, 4, 0, and 2. 4, 0, and 2. So first they want us to find the area of the triangle with these vertices. So let's find so here's my A, here's my B, here's my C. So we want to find AB and AC. And So that would be AB, finding the vector AB, and then finding the vector AC, and then taking their cross products, and then so the area is going to be equal to the norm of AB AB cross AC over 1/2, so over 2. So that would be the area. And the normal vector would be AB cross AC. So this is the normal vector of the plane containing these 3 points. So yeah, let's find what AB and AC are. So AB is equal to 4 minus 3, which is 1, 5 minus 2, which is 3, 6 minus 1, which is 5. Then the vector AC is equal to, okay, 4 minus 3 is 1, 0 minus 2 is -2, and 2 minus 1 is 1. So these are our 2 vectors. Any questions so far? So then AB cross AC is going to be equal to I, a J, K, of the vectors 1, 3, 5, 1, -2, 1. Okay. And this is going to be equal to I times 3 minus minus, so plus 10, minus J times 1 minus 5 plus K times -2 minus 3. So this is going to be equal to 13, 4, oh sorry, minus, and then, so yeah, 4, and 5, -5. Okay, so now the area of the triangle is equal to the magnitude of this thing. So it's going to be the square root of 13 squared plus 4 squared plus 5 squared all over 2. So that's the area of the triangle. The plane containing the 3 points, well, we know that this is the normal vector. So my plane is going to be of the form 13x plus 4y minus 5z is equal to, and now we just need to find a point, we just need to take one point in the plane to continue. So let's just take the point A. Actually, it might be easier to take the point C. Actually, I'll try with both. Okay, so let's take the point A. 3, 2, 1. So this is going to be 13 times 3 plus 4 times 2 minus 5 times 1. So this is equal to, so this is 8 minus 5, so this is 3. So 13 plus 3 No, sorry, times 3. So 14 times 3. Which is equal to 42. Okay, so our D looks like it's 42. Okay, so let's just make sure that this works. So let's one second. Sorry, someone just texted me something important, so give me 1 second. Sorry about this. Okay, so let's try the point C. So the point C is 402. So 402. So 13 times 4. Well, already. Okay, plus 0. Minus 10. So 1 second. 40. Oh no, this can, let me see, 13 times 4. Minus 10, 42, perfect. Okay, any questions about this? Nothing? Okay, so then the last question over here is they ask, is there a plane that contains the point A, B, C, and D? So we know the point that contains A, B, and C. So now we just need to check whether it contains D. Because there's only one point that contains A, B, and C, unless they were lying on the same line, which they're not. Yeah, so there's only one plane that contains these, so, and we found it, so now we want to see if D is also contained by that same plane, and if it's not, then the answer is no. So D was, D is equal to 5, -2, and 3. So 5, -2, and 3. So let's plug it in. So it's 13 times 5 plus 4 times -2 minus 5 times 3. And we want to know whether this is equal to 42. So, okay, so 13 times 5, 1 second, 65. Okay, minus 8. Minus 15. So this does look like it's 42. So I guess the answer is yes, right? Any questions? Okay, so that was question 5. What is question 6? Oh, sure. Okay, so that was this test. Any questions about it? Any questions about the test or anything?
Is our exam going to be 10 questions like this?
What?
Will our exam on September 23rd be 10 questions like this?
I don't believe it's going to be 10 questions. But yeah, this is like a practice. This is how it would basically look something like this. So 5 questions. Yeah, it's basically it. And this is how it would look. This is a practice exam. So yeah. Anything else?
We didn't really go over physics problems in the book. Do you think that we should review those, or do you think that really won't be a thing for the test?
Probably won't appear. It probably won't appear. Again, like the torque is the only thing, and know how to decompose a vector into its components, but I would focus much more on the, like what the equation of a line is, what the equation of a plane is. So like you can see, none of these questions have anything to do with physics. Next class, we're gonna go over another test like this, and I'm gonna try to post a few more so you guys have a clearer picture of how it's going to look. Anything else?
Were these practice tests made by you or the course coordinator?
No, they were made by the course coordinator, and he's going to make, he's making the tests in general. So these are basically how they're gonna look. So yeah, know what the cross product is used for, know some of the properties for it. I would recommend that you either go over the videos that I put on YouTube or on the page, in the pages on Canvas, there's a link to the coordinator. He made some videos and some stuff, so you some slides, so you can take a look at that. Any other questions? Okay, then have a nice day, and I'll see you next week.